the sound. Okay, guys, today what we're going to do, we're going to introduce you into the coordinate plane. Basically, you've always thought of it as a graph. We're giving you formal mathematical terminology to make sure you guys are understanding what we're doing. When we do our graphing today, a graph is just a place on a point defined by an ordered pair on a coordinate plane. Normally when we look at the coordinate plane, we put it together. So I'm going to put it together for you up here. Looks like this. Two number lines that intersect, that are perpendicular. In other words, they cross each other at 90 degrees. The X is your horizontal one. The Y is your vertical one. When I put them together, they go on forever. Now, quick little hint. I always like to label them right away so I don't forget what's what. If I look at the letter X, is there any indication if that's up or down? No, it's the same both ways, right? Instead, I need to look at the letter Y. Does the letter Y go more up and down or left and right?
Up and down.
Up and down. So Y is my up and down. Well, if Y is the up and down, what's the other one got to be? X. Okay? So if you struggle remembering what's X and Y, remember the Y tells you. The Y goes up and down because it's up and down. The X doesn't really help you much, but once you know the Y, you know the X. Ordered pairs are just a set of numbers that are used to locate points position in a coordinate plane. They are always, and I stress this, always listed as parentheses, X listed first, a comma, and then the Y. I say this is an always. There's no exceptions on this. Every mathematician in the world, if you give them an ordered pair, will put it at the exact same place in the coordinate plane because it never varies. Okay? So you must be very specific on that. An ordered pair must include the parentheses, must include the comma between the two numbers. Origin is an extremely important term, guys. Almost everything that we're doing with graphing, you're going to hear origin over and over and over. Why? Because origin is where it all starts. Origin is this point right here called 0, 0, where my two number lines cross. Okay? Everything we do originates through origin because that's where my entire coordinate plane begins. So get used to hearing about origin. Get used to talking about origin. It's going to become, you guys probably get tired of it by the time we're done. But we always go through the origin. Questions on the terminology piece? Okay, so let's look at a building an actual graph. And guys, you got a test on this next week. Okay? Mid-module, this is actually the last two lessons for this half of the module. So we're going to do a quick check, see how well you guys have learned the first half. That's going to be on Tuesday and Wednesday of next week. So you guys will be Tuesday. P days will be on Wednesday for those listening at home. When you are building a graph, here's the parts that always get the students. Most of them actually can do okay on the ordered pair piece because it's not that hard, but you forget the specifics. So let me put them here for you in no uncertain terms. First thing I need to do, put a title above the graph to describe what it's about. The whole idea of a graph, guys, is it gives me a very quick, very visual picture of an entire situation. So when I look at my graph, I should be able to tell the entire story just on what I'm seeing. I shouldn't need any additional information. The title's a huge piece of it because it's telling me what the whole graph is about. Then I'm going to label my two axes. I need to include units where possible. Okay? The x-axis is on the bottom, the y-axis on the left side. Next, I'm going to determine my interval for each axis. That's little side notes. The individual axis has equals intervals, but the x and y don't have to be identical. So in other words, if I go back up here to the one I showed you, I could do my x and I could go by tens, 10, 20. Then I can do my y's and I can go by hundreds, 100, 200. That's okay. I can go as long as I'm doing the same interval on each axis. So here I couldn't go 10 and 100, that wouldn't work. Once I've decided that interval, it repeats for that entire axis. Once I've done this interval, doesn't matter what it is, but once I've determined it, that repeats for that entire axis. Does that make sense to everybody?
Yeah.
Okay. It's kind of a fine point, but it is important to note. Once I have done my title, labeled the axis, made my intervals, now I'm ready to actually begin the graphing piece. To graph, I'm going to plot the points x and y. The x-coordinate is always first, and it always goes left and right. The y-coordinate is always second and always goes up or down. One I've heard is you have to run before you climb.
Run before you run.
Okay? So you're always going left and right first, then you're going to climb up or down. Questions on the building of the graph? Okay, let's do an example to make sure you guys can see exactly how this is done. So the first thing I'm going to do is we find the number of cups of sugar needed for each pie Carrie makes. She has to use 3 cups of sugar. So what is going to be the first part of my table? Michael? Label what? What is it? Yes, but what are the labels?
Pies and sugar.
In that order?
Yes.
Why did you put them in that order?
Because it comes first in that order.
What comes first? So you're saying pie came before sugar.
No. Well,
That's what you just said.
I was saying that, but like, I didn't read it.
Oh, you didn't need it. So now that you've read it, since I marked the text for you, what comes first?
Sugar.
So what should be my first column?
Sugar.
Sugar. What should be my second column?
Pie.
Okay? So, and here's one I saw. Most of you guys actually did better than I saw in my A2 class. But once I've used variables, I need to identify them. So S is my sugar. And where possible, guys, use your interval, your labels. So that's cups or units. So S is sugar in cups. P is, and actually I'm going to say number of pies. Yes, Mary? I normally just put it in the first one. You can do either way. If you put it above, I would not count it off of that. But normally, I include it as part of the table. So, what's my first entry? My second entry then, my first entry was my labels. Still? 3 to 1. Does everybody agree with that?
Yes.
Nobody disagrees?
Everybody.
Wait, can you say it again?
You said 3 to 1. Everybody's okay with that?
Yes, that's good, because it says 3 cups of sugar, so that would be correct.
That is correct. So, what's my next entry? Avery? How did you get that? Okay, so you added 3. Pies, you added 1. Guys, the reason I asked that is critical for showing your work. Had he said I took it, that first one, and multiplied it, that means I'm looking at it from multiplicative. I had to put times 2 to show my work. So I'm just trying to mirror what he's telling me and how he's getting there. So now that we've decided we're looking at this from an additive standpoint, for my work, all I'm doing is putting the plus 3, plus 1. So my next entry is going to be 9, 3. And now again, just to reiterate, when you're showing your work, I want to see it at least twice. But I'm not going to make you write it for the whole table. If you want to, that's awesome. I'm not going to count it off. But you need to show me at least the first 2. Okay? Now, I am actually going to add a piece over here. So I'm going to move my work over. So I'm going to add another column. Because we're now going to graph this, I'm going to turn all of these values into ordered pairs. So making ordered pairs, once you've got the table, guys, is very, very easy. Why? Who remembers yesterday, last class, I said the first column is what? X or Y?
Y.
X. The second column is
Why?
Why? Here's why I was telling you that. Now's where that comes to fruition. Because my ordered pairs are all set up as x comma y, right?
Yes.
So what's going to go first in my first ordered pair?
3 to 1.
3 comma 1. And I put it in parentheses.
Okay.
Now I have an ordered pair based on my table. My second one would be 6 comma 2. 9 comma 3. You guys get the idea?
Yes.
It's pretty easy, right?
Yes.
If
What?
you can build the tables, which should
Oh, I
be
get
easy
it.
at this point, making the ordered pairs off of the tables should be extremely easy.
Super.
I have a note bar.
Okay, so now that we've got the table all complete, we're ready to begin doing.
No, wait, don't do it.
Do it now.
No, wait, I'm thinking this
Sorry, just looking at Wyatt, not even writing anything, didn't borrow a piece of paper. Okay. Good thing she's nice. What's the first thing I need to do to build my graph? Michael?
Label the graph.
Label it?
Yes.
Was that the first thing? Did you not read your notes that we just went over? Or any quaffles?
Put a title above the graph.
Title! So what should I title this? What's this graph going to be about? Avery? Okay? Sugar and a pie. Last class I called it Carrie's Pies because she was making pies. Sugar and a pie works, all right? Because that's kind of what we're talking about.
Yes.
So, now Michael, what's our second thing we do?
Label.
Label! I need to label my X and my Y. So what is the X-axis? What should I label this?
Sugar.
Okay? Sugar, because it's about sugar. But then we also use units where possible. So that sugar is being measured in cups, so I'll put that in parentheses beside it.
Okay.
What about my Y-axis? What is that? And I also, guys, will normally label that X and that Y just to help keep me straight. Yes. Pies. What about the pies? The number of pies. So I'm going to put hashtag pies.
Is this sugar and that is that a
Sugar cups. That's a C for cups.
I told you.
Hashtag?
Number of pies. If you want to write it out, number of pies, feel free. I like hashtags. And now, next step, we need to make our intervals. Now, one thing about this, my intervals must all be even. Okay? So even though they're even on both the X and Y axis, that doesn't mean the intervals themselves have to be the same. What interval do you think we should use for our sugar?
3.
3, right? Because it's done by 3s. So I can do my sugar in 3s. 3, 6, 9, 12, 15. What am I going to do the pies by? Am I going to do that in 3s as well?
No.
Is it okay if I don't do 3s?
Yes.
Yes. Mary?
Does it matter how many lines you put in between?
No, as long as they're equal. Doesn't matter, and you'll see that when we actually use a graph paper. I can use whatever amount I want, but I have to keep it equal. I can't use 3 for the first interval, and then 2, and then 3, and then 8. Once I've decided how far apart the intervals are, every interval has to be the same amount. Okay? Absolutely. I highly encourage it, actually.
I don't believe you.
Actually, once we get to the last part, you're going to have to use a ruler. So going, again, we're back to this question. Going up on the pies, what interval should I be using? 1s. Why? Because that's what's on my table.
Yes.
Okay, we have now set, we are finally ready to begin our graphing.
No.
Yes, we are.
There we are.
So,
So, watch this, guys.
Finish with the note.
Oh, let's get ready, guys.
Every time I graph, I do the exact same thing. And that's what allows me to graph accurately. That thing I do is I always take my pencil and I put it on origin, my 0, 0. Very first thing I do. Then I read my ordered pair. In this case, it's 3, 1. So that means from the origin, I'm going to go right 3 because it's positive. Then I'm going to go up 1 because it's positive. Right now, all we're going to deal with positives to make it easier for you. We'll get to negatives later in the year. Then, guess what I'm going to do? What do you think I'm going to do, Lori? What do you think I'm going to do? go back to origin. Then my next one, I'm going to go to 6, and then up to 2, and then I make my dot. Now, do you want to guess what I'm going to do, Lori? It is Lori, right? Do what? Good. Go back to origin. Told you guys to get sick of this. Because every time I do this, I go back to origin. I go over to 9, up to 3, and I make my dot. Alberto, guess what comes next? Alberto, guess what comes next? What? Oh, yeah, my apologies. Angelo. What am I going to do? You know what I'm going to do, Angelo? I'm going to go back to origin. Then I'm going to go over to 12, up to 4, make my dot. My last one, I'm going to go back to origin, over to 15, up to 5, make my dot. Here's where you guys need a ruler. If you're not using a ruler on the test, you're going to get in trouble. Because this line must be straight. Okay, I can't use one on the smartboard, or I would. But now that I've got all my dots laid out, I'm just going to take my ruler and I'm going to line it up. Make my line. Yes, Mary. Hey guys, I don't need a bunch of conversations to go get rulers.
This is my favorite.
Listen up. Mary? What do you mean, which one I do first? Always do X, then Y. Okay, guys. Mary asked a good question. She asked, does it matter which one I do first? Can I do the 1 first and then the 3? No.
No, absolutely.
Always do your X first, then always do your Y. Technically, could I do the 1 and then the 3? You could, but you need to get in good habits now. Guys, you are going to be graphing through at least Algebra 2. You will be graphing into calculus. So this is something you're going to be doing for the next 6 years at least of your academic life. You need to develop good habits now. Good habits is start at origin, do left, right first, and then go up, down. That will keep you from ever getting confused. Okay? So once I've got my line drawn, I must put an arrow on it. Did anybody not hear me? Raise your hand if you heard what I said.
I heard you.
I see some hands that are not up. Let me say it again. Once I've drawn my line, I must put an arrow on it. Why? Because that line goes forever at that trajectory. Okay? So it doesn't end right there at 5:15. It'll keep going. Questions on the notes? Okay, I'll give you 1 more minute to finish writing the notes and catch up before we move into the module. Okay, guys, we're running out of time. So, we're about to hit fast forward here. Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown for a tournament. The distance between Yonkers and Morgantown is 400 miles. The total trip will take 8 hours. Train schedule is provided. They show us all the different locations and how far away they are. What you'll notice is they're going from leaving Yonkers, going to Morgantown, then they go Morgantown back to Yonkers. So you're seeing the exact same towns. The nice thing is they gave us nice even intervals. So what they want us to do with this information now is create a table to show the time it will take Kelly and her team to travel to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. Extend the table to include the cumulative time it will take to reach each destination on the ride home. So in English, what they're saying is, build me a table, pretending you don't make a stop for the soccer game. So they only want the travel time going to Morgantown and then back. So, given this information, how long do you think it's going to take them to reach their first destination? Yes? Huh? So, 16 hours to go 100 miles on a train? Have you ever seen the trains on the high-speed trains?
Yeah.
How fast do you go, Avery? Yeah. How long do you think it's going to take a high-speed train to go that 100 miles? They're not that fast. That is some serious high speed.
80 miles an hour?
Well, I'll give you a hint. We have hours and miles. So I think the first entry in hours would be, Neil? 1 hour for 100 miles. Okay? What's my next entry going to be? Winner?
You don't have a note.
How did you get that?
That did.
So you added, okay? So she's doing additive. Hey guys, too much conversation going on. Everybody needs to be able to hear, please. So Winner looked at it from an additive perspective, so that's how we'll continue. So on this side, I'm going to add 1. Gives me a 3. On this side, I'm going to add 100. It's going to give me 300. There we go. Why it works the 5th time, I have no idea. So show me your work at least twice, guys, when you're doing additive. If you're doing multiplicative, show me every time what you're doing. Because multiplicative, it's much more likely I'm going to make jumps. And I need to understand from your work that you've made bigger jumps than just going up by the next one. Okay? So overall, we've got 8 stops. 100 miles per stop gives us an 8-hour trip. My first column just goes 1 to 8. My second column goes 100 to 800. Okay. Oops. Skipped one. My apologies. So now we're going to create a double number line to show the time it'll take to travel from Yonkers to each town listed in the schedule. Extend the double number line to include the cumulative time it will take to reach each destination on the ride home. Represent the ratio of the distance traveled on the round trip to the amount of time taken with an equation. So there's actually several things we're doing here. Create the double number line. We're extending it to include the return trip and write an equation. So, to do my double number line, Tom, what do you think the first thing is I need to do? Mark 0? Good. So my first interval is 0, 0. Well, there's one other thing I should do before I even do that. Mary? Label it. What am I comparing? Hours to miles. So I'm going to use the abbreviations H and M. So H is hours, and M is miles. So I got my 0, 0. What's my next entry going to be, Cameron? What's my next entry going to be? You can look at the table if you need to. Yeah, so you can look at the table if you need to. What's my next entry? 1 to 100. Then I'm going to go to 200. Basically, guys, I'm just taking that table I just made, turning it on its side. That's all a double number line really is. We're not going to do anything additional with this today because I want to get to the graphing piece, but we do need to build the equation. The equation is actually still the same as we did on the table. This wasn't so easy to make me smile. So how would I make my equation on this? I think Neil. What comes first? I'm building an equation. Hours, okay. So H equals what? So I started here. Here's where my smile comes in. What number did I hit first? No? No? That's the letter I hit first. What number did I hit first? 1 over 100. The other variable is M. Could I have done it the other way?
Yes.
Yes. If I did it the other way, M equals what? 100 over 1 times H. Or 100 over 1 simplifies to 100H. Guys, are you okay with these equations? Good, because there's 2 of them on your test. Okay, we're going to skip the rest because I want to get to the next part.
Wait, what did you do?
Guys, please. Thank you. So dinner service starts once the train's 250 miles away. Minimum time they'll have to wait before they can have their meal. So there's our question. So our table we're just going to recreate from the previous one. We're going 1 through 5, 100 to 500. Ordered pairs. Awesome. How do I build my ordered pairs now?
I know how to go right over.
How do I build my ordered pairs? What does it look like? No? What do you think, Noodle? Good. Parentheses what?
100.
Good. She got everything. Parentheses. 2, comma, 200, parentheses. We must have parentheses around our ordered pairs. We must have commas between the numbers. Okay? Questions on making your ordered pairs off of the table? Pretty easy, right?
Yep.
Let's talk about the actual graphing now. What's the first thing I need to do on my graph?
Label it.
Label it. No. What's the first thing I need to do? Title it. What are we going to call this one? What are we doing, Lori? What about time? Title of it. What are we going to call it? Guys, Lori's right here and I can't hear her because you're off. Stop. Miles what? Miles traveled? Okay. I'm going to change that a little bit. We'll just say train traveling. Okay. So we're traveling on the train. Now we can do our labels. What's the labels? What's my X?
Hours.
Michael?
Hours.
Hours. What's my Y?
Miles.
Miles. Okay, so we're hours and miles. What's the next thing I need to do? What do you think, Wyatt? We did that. Hours and miles. No. I actually would encourage you guys to put the X and the Y on there. I probably won't count it off on the test. I'll see how Miss Petrel's on that one. Dom? Numbering. Good. So I need to make my intervals. So do I have to use every single space?
No.
No. So look at my graph. How many numbers am I looking at doing? 5. So how many spaces do you think I should make if I want to go 5? Okay. If I go every 5, I probably won't have enough. I'm going to go every 4. So I'm just going to count. Every 4, I'm going to make a little mark. And that's going to show me what I'm doing. So I'm going on by 1 on the hours. So every 4, I'm making a mark. And then I'm putting the number associated with it.
Yeah, what?
This is identical to the one in your book, so it should work. What about going up the side?
4.
Good. Guys, once I've determined the interval, I keep that interval on the side, but I don't have to number it the same. Make sense?
Yeah.
So I still want to go every 4 going up. Okay? But what numbers do I want to use on the side now? Oh, I missed that. Are you kidding me?
100.
Okay, I need to go up now by hundreds. So that's going to be 100, 200, 300, 400, 500. Okay? Now that I've done all that, now I am finally ready to actually plot my points. So, where do I start to plot my points?
The origin.
Origin, good job. So I start at origin. I go over to 1, up to 100, I make a dot. I go back to origin. I go over to 2, up to 200, I make a dot. I start at origin. I go from 3 up to 300, I make a dot. I go back to origin. I go over to 4, up to 400, I make a dot. I go back to origin. I go over to 5. I go up to 500, I make a dot. Once I have all of my dots on my graph, now I use my ruler. I draw my line straight up, and I include an arrow at the end to show it goes on for eternity. For eternity, goes forever. Okay, so guys, next page. This is your homework. Go ahead and carry it out. Page 59 and 60 are back to back. This will probably look very familiar to you. If you look at page 59. Page 60 is just a different one. One other piece on this, guys. Write a story context. So this one, they didn't give you a story. So you need to basically make a word problem that shows a ratio of 1 to 4. That word problem is going to give you your title and your labels. So everybody's will be different. That's page 60. That's those 2 pages. Okay, guys, real quick, go ahead and turn to page 66. Carry it out as well. Page 66. Okay? 59 and 60 are back to back. 60's on the separate one. Guys, pay attention to this one. Please stop. Guys, do you not hear me talking? Page 66 is a very difficult problem. You need to do exactly what it is telling you to do. It is saying to make a table to show the first, second, and third hours after posting. They gave you 500 at 4 hours. They gave you a value in the middle of it. I will warn you now. This is at 4. That's how many views there are. To find 1, I divide the 500 by 4. Then I can use that base value to build the rest of my table. You have to have that, because now you got to do an equation to represent it. You're going to use a table to make a list of ordered pairs. You're going to graph the ordered pairs, and then you're going to predict how many views there are. So multiple tools could be something like your graph and the table, which you've already created. Okay? To show me that you're using both of them to make the guess for after 12 hours.
Okay, guys, we are on page 64. Let's look at this question. We're looking at tablespoons of water to number of eggs. How many eggs to every? No. 3. Good. Let's fill out our chart. Okay, so what's our next number? 6. So we're going plus 3. Plus 3. Okay. I'm going to put these over here smaller so we can do our ordered pairs. All right. Now, guys, let's make our ordered pairs from this chart. Okay, are we good? All right. So here are our ordered pairs. Okay, what's my first ordered pair?
2, 3.
2, 3. Good. We have our X and our Y. 4, 6, 6, 9, 8, 12, 10, 15, and 12, 18. All right, let's look at our graph. Remember the things we have got to put on our graph. What's the first thing?
Origin. Oh, title.
Title. Okay, what can we title this?
Eggs eaten. Number of eggs.
Huh? 1 to 10. Okay, so earlier they put pasta recipe. I don't know.
No,
Okay.
I'm 5.
All right. We've got our origin. Somebody said the origin. What else do we have to put on here?
X and Y.
X and Y.
Okay.
Here's our X and our Y. And then what else? So, yes. Labels? Yep, what labels? Here's our X, here's our Y. So water, and then you want to put how it's measured in tablespoons. Okay, Then what's up the y-axis?
Eggs.
Eggs. Okay? Nice. Okay. All right. So start labeling. This is not cooperating. Yeah, 1, 2, 3, 4, 5, 6, 7. We're labeling by ones, guys.
Hey guys, while she's doing that, I've seen a lot of people not putting parentheses around your ordered pair.
Yeah.
Remember, by definition, ordered pair has parentheses around it.
You go all the way up to 12. Well, I mean, you don't have to because on forever.
Okay, we're going by ones, guys.
Oh, I went by 3.
So 2, first ordered pair is 2 over 2 up 3. Here's my first. And then the second one is 4, 6 over 4 up 6. 1, 2, 3, 4, 5, 6 over 6 up 9. All right, over 8 up 12. 10, 11, 12. Over 10 up 15. Over 12. Up 18. Okay, so we started our origin. Guys, use your ruler. And make sure to put your little arrow at the end. Yep. Any questions so far? All right. It says, what would you have to do to the graph in order to find how many eggs would be needed if the recipe was larger and called for 16 tablespoons of water? What would you have to do? If it called for 16, yes.
We need to add it to your chart.
Yeah, extend the graph, right?
Yes.
Okay. Okay, so go back to your graph. Okay? Go back to your graph. And if it called for 16 tablespoons of water, here we are at the end, 16 tablespoons. How many eggs would we need?
4 more.
So how many?
6 more.
20? What do you think? So if we kept going, 14, 16, right? How many would we need?
No, 22. 22.
Guys, look at your chart. Look at your chart. If you were to extend it, how many eggs would you need if you were to extend it to 16 tablespoons of water? Yes. How many?
6 eggs. Oh, 2.
How many eggs would you need?
6.
24.
What the? Oh, no.
I know what you were doing. You were saying how many more eggs would you need. It was talking about total eggs.
She pointed out, and I'm like, okay, Michael, can I take a picture? No. Okay. I went down. Ow, I didn't know the belly.
Good. If you extend your chart out, guys, you will be able to see that. Okay. Very good.